So we're given this function y equals x cubed minus 2x squared plus 3 times 7x squared minus 4x, and we'd like to know its derivative. And one option would be to expand this, right, multiply those together and then take the derivative, given what we know. But there is another option, right, and this is really an example of a function, right? So y equals, that's the product of two other functions, right? It's f of x and g of x, right? Or to simplify the notation a little bit, we could say that this is the product of one function u times another function v. And so besides expanding them, another option is to consider what's called the product rule, right? Is there another way to take the derivative when you have a function that's the product of two other functions? The answer is yes. And the notation that I like to use for this goes like this. We're going to take the derivative of the first function, so u prime, and multiply it by v, and add it to the product of the original first function, u in this case, times the derivative of the second function, in this case v prime. Now your textbook uses the same kind of notation, and by the commutative property probably has something like this: u v prime plus u prime v. I would encourage you not to memorize it that way, right? It's the same thing, just using the commutative property, but this order is useful for another property that we have, and so there's going to be less to memorize if you memorize it in this order, right? Both are right, but I just prefer that order. So how does it apply here? Well, in this case, u is the function x cubed minus 2x squared plus 3. V is the function 7x squared minus 4x. So we know that u prime is equal to 3x squared minus 4x. V prime, or the derivative of v, would be 14x minus 4. So if we put it all together, since the derivative of y, our original function, is equal to u prime v, or the derivative of the first function times the second, plus u v prime, the first function times the derivative of the second, then what we have is, for the derivative of y, 3x squared minus 4x u prime times v, 7x squared minus 4x, plus u, which in this case is the cubic x cubed minus 2x squared plus 3, times the derivative of the second function, or v prime, in this case 14x minus 4. Now, is this form kind of disgusting? Yeah, it is, but this property is super helpful. Now, unless there's a good reason to multiply these things together and combine like terms, do not spend time doing that. Right? It's kind of a waste of your time. This entire nasty looking thing is an expression for the derivative, and it's absolutely fine if you leave it like this, unless there's a good reason not to. The directions tell you to simplify or something like that. But I don't want you to be in the habit of simplifying just because. That's the product rule. Now, just to give you a second example, let's say that we want to deal with a function y, which is being defined as 1 plus the square root of x, so this is u, times x minus 2. Well, the derivative of y, or y prime, is equal to the derivative of the first function, which would be 1/2 x to the negative 1/2, times the second function, in this case x minus 2, plus the first function, 1 plus the square root of x, or u, times the derivative of v, which in this case is 1. Right, and again, you don't need to simplify. you can if you'd like to. This one's not too bad to simplify. You would have 1/2 x to the 1/2 minus x to the negative 1/2 plus 1 plus x to the 1/2 power. And this is equal to 3/2 x to the 1/2 minus x to the negative 1/2 plus 1. This is correct as an expression, but again, unless there's a real good benefit for you to be spending your time simplifying, don't do that. This is just as acceptable. The product rule.